Okay, so here we go. So the last thing I want to do here is show on this slide deck is how can we iterate linked lists. So we had a prior slide deck where we showed how you can iterate across an array list. So why don't we see what are the approaches we can do to iterate across a linked list. So here we'll just do some quick examples, 3 examples. The first example, we're going to show how we can iterate using a for loop, an enhanced for loop, and a while loop, right? Super simple ways that you should have learned how to iterate over basic data structures in 1583. Then we'll look at using the iterator, the universal iterator, the one that we get from the collection interface. And then we'll look at using the list iterator, the one we get from the list interface. Remember, this iterator only gives us a forward direction. The list iterator gives us a forward and backward direction that we can traverse. So with that said, let's just kind of introduce the concept of what we had. So in the last lecture, we had discussed that linked lists and its various methods with various example programs, right? In this lecture, we'll show you how to iterate linked lists in Java. So before going on this topic, if you're unclear about linked lists, go back and look at those slides. But really, these are for references for using this as a kind of like as a set of books or chapters is why I make those references there. But here we'll look at the for loop, enhanced for loop, the while loop, iterator, and list iterator. Okay, so let's create a application where we use for loop, enhanced for loop, and the while loop all in the same application. So I have it here, but I can also just open this up in my IDE. So let me do that. So here I'm going to import linked lists. I'm going to create a class, iterate linked list tester1. I'm going to create a main method. We'll create a new empty list of data that holds string data types. We'll add red, yellow, green, and white to our list. We'll print out, we'll use a for loop. So we're using a for loop. We can go ahead and let's say we want to loop through all of our elements. So I will start at index 0, right? Because that's the first position is always index 0. Then we'll go until we get to the size of the list. So there's a size method that we can use to control our for loop. And then we'll just use our incrementer there. Then we'll use the get method on our list to be able to get the value at that position in our linked list. We'll grab that element and then we'll print it out. So that's an example of how we can use a for loop. To use an enhanced for loop, we don't have to use any of the setup. We don't have to know any of the position stuff, right? We can just create a local variable of whatever data type is held in this collection. Then we do colon, and then we pass a reference to the collection we want to walk across. And then we can just use inside of the for block, the enhanced for loop block, we can just use whatever the local variable is declared there to access each element. And so here we'll just print out all the elements. Now, again, an enhanced for loop is super powerful and great if you're reading data from a collection. But if you need to mutate the state of a collection, usually you need the position number that where you want to mutate it at. So then you would use a traditional for loop. If you're using these primitive iterative methods. And then with the while loop, you would have your loop control variable, the index starting at 0 effectively. And then while our indexer is less than the size, then we would just use that value, that index value, the loop control variable to get that value, and then we would increment it up. So again, while loops, for loops are exactly the same. It just exposes the implementation details for the loop itself in your logic. Okay, so if I were to run this, this would go ahead and give me the expected output, right? So for let's expand this out. So for a for loop, we get red, yellow, green, white. All right, those are the values. For an advanced for loop, we get red, yellow, green, white. Yep. And then for our while loop, red, yellow, green, white. Okay, so that's the primitive way of doing that. But now that we're learning how to use the collection framework, we want to go ahead and do this in a more sophisticated way. So here, why don't we make a program that uses the Universal Iterator? Now, remember, the Universal Iterator it's more broad in what collections it can be used on, but it's more narrow in how operative it is. So here we're restricted to just a forward direction. And so let's go ahead and create some very easy source code. Let's actually open this up here though in the IDE. So my IDE, I'm going to go ahead and import Iterator so I can get a reference to an iterator. I'll import my linked list so I can actually build a collection of linked lists. I will go ahead and create a class and a main method so we can actually create an application that runs. I'm going to create a variable of data type linked list that will hold characters. I'm going to use the generics there. I'm going to invoke the constructor here. Then I'm going to add the car A, B, C, D, and E into my list. Then I'm going to ask the list for an iterator. So I do a .iterator call, and I'm going to store that iterator. So I'm going to use the generic typing there. So iterator, data type iterator, and iterator that returns characters. And again, since this is a primitive data type, we have to use the reference data type whenever we use these collections. And I'm going to use the name iter on there. And then I'll do this loop where I can query the iterator if there's something next. And if there is something next, to go ahead and give me the next thing that that the cursor is looking at in the iterator. So while iter has a next value, we will get that next value. We will store that in our object and we'll print our object out. Okay, let's go ahead and run that. And so there we go. Using the iterator, we have A, B, C, D, and E. And so that's our expected output. And then in order to iterate our linked list using the ListIterator, right now, the advantage of the ListIterator is since a linked list implements the list interface, we can go forwards and backwards using the ListIterator. So let's create some basic source code. I make it available on the slides, but I'll also have this available on the GitHub so that you can go ahead and import this code into the IDE and you can test it out for yourself and see how it works. And then you actually mutate it as well. You play around, change values if you want, or add to it, remove it. I encourage you touching code as much as possible, just so you get more used to actually working with it. So it's just one thing to hear me lecture a lot, but it's pretty important that you actually do these, practice these concepts we talk about. Okay, so we're going to import our linked list from the java.util package. We're going to create a class, linked list tester 5. We'll create a main method here. We'll create a variable of data type linked list that again is going to hold characters. We'll use the reference data type that is given to us from the java.lang package. We'll create an alias for that list, and we'll just create a new empty linked list there. And then here, we're going to add our elements A, B, C, D, and E. And then what we'll do is we'll even take our list, we'll print it. Oh, wait, this is not quite what I want to do here. This is what we're doing with, so I think this is my pushing and popping code. Oh, I think I must have overridden. Well, that's okay. Let's modify this. Let's take our code. Oh, wait, no, I need to open up. Okay, this is what we need. Iterate linked list 3. Yeah, this is looking much better. Well, like code that we're actually using for an iterator. Okay, so here we're going to import java.util linked list, and now we're going to import a list iterator from the java.util package. That looks much more appropriate because we're going to need to hold a reference of that. We're going to create a class here, iterate linked list tester 3. We're going to create a main method. We're going to go ahead and create a variable of linked list that's going to hold integer values. We'll hold that in our list variable and create a new linked list while we do that. We're going to add some int values. And again, since int is a primitive, we can't hold primitive type. So we're going to use the actual integer reference type that's given to us by the java.lang package. Here, we're going to add in some integer values, 10, 20, 30, 40, 50. We're going to print out the initial state of our list. Then we're going to go ahead and from our list, we're going to call that ListIterator method. And remember that ListIterator method we had to implement if we claim to be a member of the list interface. And then I'm going to save a reference of that ListIterator. And this list iterator returns back integers. It has to be the same type of the collection that this holds. So these have to match in the generics. And we'll give it a name of litter. Then what we'll do is we're going to go in both directions. So we'll go in the forward direction. So while there is a next value available inside of our linked list, we will grab that value and we will save it into object, and then we'll print it out. And then after we've walked our iterator all the way across so that the cursor is pointing to the tail of our linked list, then we're going to walk it back the other way in the backwards direction. So while there is a previous reference to our cursor and where its position is at on our collection, then we will go ahead and tell that cursor to go to the previous node or the previous index, and then we'll go ahead and grab that object and we'll print it out. And then we'll even try to add to the list itself. So we'll use the add method on our linked list 60 while we're in the middle of doing this iteration, and that should throw that concurrent modification exception we've seen when we were doing this with array lists. And again, if we want to mutate the state while we're using an iterator, we should use the iterator to do that, not the methods inside of our list. And the reason why our list knows to throw this is that it is intimately tangled with the iterators. There's a reason why we're not calling the constructor with an iterator. The reason why we have to ask the list for an iterator is that iterator gets registered to the list itself, so it can throw these exceptions. So it can be in a position where it doesn't allow you to do something dangerous and get your iterator out of sync with the data that is supposed to iterate across. So the iterator is actually an inner class. It's like a nested class of the collection itself. And so that's why we use the factory method, where we ask the class to build that object for us, and then we get that instance of an object. It's because that instance of linked list or array list or whatnot is going to also kind of cross communicate with the iterator while we use it. So that since they're codependent on each other, it makes sense that one class is defined within the other. And so let's run that. And here we'll see our output is going to be the linked list. The original order is 10, 20, 30, 40, 50. If we just print out the initial state, and then as we iterate in the forward direction, we start at the head, so 10, and then the 20, then the 30, then the 40, and the 50, and then we can't go any further. So our while loop ends, and that's when we'll go ahead and then decide to start going in the backwards direction. Here we'll do the 50, but inside of our while block, we're like, hey, let's see if we can add the 60 here. And since we did that, it throws that exception, concurrent modification exception. Now, if I comment that out, right, it'll actually walk all the way back entirely. So if I do that and comment that out, you'll see it goes 10, 40, 30, 20, 10, and then print out the state of the array, the original state, the unmutated state. Excellent. And so okay, but I'm going to put that add back in so that we do get that concurrent throw, so it's consistent with my output here. Yeah. Yep, and that's the exception we got. Perfect. And that's it. That's everything we need to know about linked lists. So over the last two lectures, we went into some pretty intimate details on array lists and linked lists, and talked about reasons why you might want to use one versus the other. And so I think those concepts are critical enough that I might have you I'll probably author up a second homework assignment that just has you evaluate those behaviors and look at the performance differences, so that you'll actually visually be able to see and test that. But we'll talk about that later. But with that said, so that ends our lecture for today, and I'm out of time. Does anyone have any questions about the lecture or about the homework? Now, the motivation of going over an actual framework like this and going through the hierarchy is the first assignment is based off of Unit 1, it's essentially API programming where you're creating a piece of code that's designed as a part of a framework that's designed to be used by someone else to develop their code. I think looking at the collection framework, which is probably one of the first frameworks you've had to use, and understanding how it's pieced together can kind of motivate your own design principles so that you can see how you can design your own using interfaces as an effective mechanism to define the behaviors that your framework will have. And then you can start defining objects that can actually be instantiated that implement some of those methods. And then all of your concrete objects will just have, they'll have a subset of the interface methods. And then you blend them together to make the variety of objects that your API goes ahead and provides. Excellent. So if there's no questions, I'll go ahead and end today's lecture here. We have one more lecture for this week, so I'll see everyone tomorrow then.